Okay, so I think I'm recording now. Usually there's a little voice that says recording started, and I didn't hear it, but I think we're going. Okay. Of course, that's not quite where I want to be. Okay, this is where I want to be. Okay. Oh yeah, thank you. All right, so we're going to finish up Lesson 7 here and get a start on Lesson 8. So all of this is still talking about functions. Once we finish Lesson 8, we'll finally be done talking about functions, and then we can move on to something else. I did want to talk a little bit about some of the expectations for the when you turn in your assignments that have to do with functions. A couple of questions that have come up were space between the functions, right? So in the style conventions, it says 2 inches between functions, and my experience is that for some reason students really don't believe that I mean that. Like on the message board, I'll have people talking about it, and they'll say, someone will say, "Does he really mean 2 inches?" And someone else will say, "No, I think he means 2 lines." But I really do mean 2 inches. I look at hundreds and hundreds of these, and trust me, it's really a pain to look at it when there's 3 blank lines between the functions, because it just doesn't. The functions don't jump out at you the same way. So that's why I put 2 inches in there. When I took this class in college, the rule in all of my computer science classes in college, the rule was each function got printed on a separate page. That was back when we actually printed out our assignments and handed them in. But so in my mind, 2 inches is like, oh, that's not very much. Now, if you put 1 inch between your function definitions, are you going to lose points? No. Okay. Because I'm thinking, well, 2 inches, it could depend on your monitor and some other things, right? So I say 2 inches. If it's 1 inch, you're probably going to be okay. If it's a half an inch, you're probably not going to be okay. That make sense? So do it looks like 2 inches too. If you hit the hit the return key 12 times, you're going to be okay. So I just spent like 2 minutes talking about something that's really not very important at all. But question? If you didn't do that? Sure. I mean, the only reason I'm even hesitating is I'm trying to think about how to make sure I don't grade both. I mean, if I grade both, I would take the score on the second one. So yeah, go ahead and resubmit if you don't think you put enough space between the functions. Maybe you could also submit it to the email address where you always submit your assignments, and then send me an email on my Harden at Santa Rosa email saying I resubmitted it. That would just help make sure that I don't waste a lot of time grading 2 versions of the assignment. Okay, I think, any other questions about that? Go ahead. Right. Okay. So the question is, at some point, will I give an example of what I want, how I want the functions to be laid out, and where I want the different things, and how I mentioned in the syllabus, mentioning each parameter by name. What does that look like? I think I think that I don't actually have an example. Probably what is going to happen is that the first actual example you'll see will be when you get the solution to assignment 6. And what happens basically when I grade assignment 6 is that as long as it looks like you actually read the style conventions and you kind of gave it your best shot, I'm not going to take points off. Okay. But I will. But despite that, I'll talk about it a little more. Okay. So basically, the comments go. Trying to think if I have some code I can at least point at here. Yeah. Not lesson 7 at the bottom. Lesson 6 at the bottom, probably. It's hard to understand what you're saying. So my audio is not very good today. Is that what we're saying, Terry? Seems like since I switched headsets, it hasn't been as good. Is it? It's better when you talk into the microphone. That's confusing because I haven't moved the microphone. But you know, I did play with something on the microphone that might have made it better. So maybe that's what happened, Terry. Thank you for pointing that out. There's a thing on my microphone that says volume, and I just assumed it was for what I was listening to, but maybe it also affects how loud it is when I talk. I don't know. Anyway, it's all the way up now. Okay, so let me actually get some code to point at, because that's an important question that I sometimes don't. I kind of skip over. Okay, so here's basically how I want your program laid out, not counting the fact that I want comments and I want 2 inches between the functions, right? So basically all you're going to do, you're going to have a big comment at the top, right? That's your initial file comment that you've been doing all along. And then above each function definition, so this is a function definition, so up here, above it, you're going to write me a comment about the function. What happens when this function gets called? Okay. How do you define what happens when a function gets called? Well, it has to do with it always has to do with the parameters, right? What the function does is defined by how it's affected by the parameters. So if you're telling me what the function does and you don't say anything about the parameters, you're not doing a very good job. Okay? So your function comment should always mention the parameters. So for example, getDimensions asks the user for the width and the height. Let's see, I'm making this up on the fly and I'm struggling. When this function is, at the end of this function, width will be the value that the user entered for the width, and height will be the value that the user entered for the height. That's what the function does, right? Now the way I said it right there is actually called a post condition. Here's what's going to be true when this function is done executing. The parameter width is going to be equal to whatever the user entered for the width. The parameter height is going to be equal to whatever the user entered for the parameter height. So that's a slightly more formal way of doing it, right? Instead of just kind of babbling a little bit about what the function does. Talk about the parameters. Besides changing parameters, if they're passed by reference, what other results can a function have? It can change the parameters. Not if they're, yeah, the comment was it could change variables, but if they're not passed by reference, it can't really do that. And that, right, if it's a local variable, it doesn't have any effect, so I don't need to explain that. There could be some output produced, right? So three things that a function can do. It could change the value of reference parameters. It could produce some output, or it could return a value that we haven't talked about that yet. Okay? So when you think about how to comment your function, think about those three things. What's going to happen when I call this function? One of those three things is going to happen. What does it look like exactly? Okay. If it's producing output, what does the output look like exactly, and what does it depend on? So for draw a box, I would say draws a box of x's with the width determined by the parameter width and the height determined by the parameter height. How's that? Okay. That may, if I sat down for 5 minutes and thought about the perfect comment, that might not be it, but that's what came off the top of my head. Yeah. 2 inches, yeah. So the question was, each one of these lines is supposed to be 2 inches of space, and the answer is yes. Okay, space between the comment and the function. Sorry. So I feel a little bit like we're getting, I'm being a little too, what's the word? Specific or whatever. So, I do have this idea in mind of how I would like things. Okay, that doesn't mean it's the only good way. So I'd like 2 inches, but if you put 1 inch, I'm probably going to be okay with that. I think the best way to do comments is to put a function, like say here, and then 2 inches, and then the function comment for the next function, and then a space, just because if they're bunched up, if the comment is bunched up with the function header, it's hard to separate the comment from the function header when I look at it, and then the function. Okay. If you like to bunch it up and you don't like to put a space between the comment and the function, I'm probably not going to take points off of that, right? But I would like you to think about it. I don't want you to do that just because you didn't think of putting a space there. I want you to do that because you think that's absolutely the clearest way that you can write your program. You had a question? Okay. I was going to finish. Did I finish talking about? I guess I finished talking about a comment for Drawbox. So yeah, I'm done. Yeah. Sure. Okay, so the question is, I have said that I prefer the curly brace here to be up at the end of this line rather than down on the next line. And in the examples you see in all of the lessons, I think that's true for everything except function definitions. For function definitions in the lessons, I'm not consistent, right? I put the open curly brace down on the next line. Couple reasons for that. One is, for function definitions, you're never going to get like really complex nested if-else statements where you have to count the closed curly braces and open curly braces and make sure they're right. So it's not as important one way or the other. The other reason is that I used to do everything this way a long, long time ago. And finally, this is when I was probably in college, at some point, I changed my mind and said, yeah, all my friends who are doing it the other way are right. It's better to actually put the open curly brace up on the previous line. And so I started doing that for everything except function definitions. And then 10 years later, 20 years later probably, I thought, that's not really consistent. I should do that for function definitions too. So when I wrote these notes a few years ago, I was still putting the open curly brace for function definitions down on the next line. But now, when you see me code, you'll see me put it back up on top. How's that for a really long explanation about something that's not really very important? Okay. Besides, it was fun. I got to tell you a little story, right? That's actually true. When I was in college, I was so determined that doing all of my if-else's and loops with the open curly brace down on the next line was the right way to do it. I don't even remember why now. And then I saw my friends doing it the other way, and after a while I was like, oh yeah, this works a lot better. So I changed. And what I have found is that most of the introductory textbooks do it with the open curly brace down on the next line, but in the real world, not very many people actually do it that way, so I don't know what that's about. Okay, it seemed like that was a digression, and I was talking about something else, and I can't remember what it was. Okay, I guess we're done with that. I know what it was. Okay, so one more thing about comments, okay? And this is actually kind of important. In earlier editions of the textbook, I don't know if she still does pre and post conditions or not. Have you read anything about pre or post? Okay. So there's these things. One strategy for writing function comments is to use pre-conditions and post-conditions, which just means the post-condition is, here's what's going to be true when this function is done executing. And a precondition is, well, here's what has to be true before the function starts in order for that postcondition to work. That's a really formal way of doing it. And actually, it's a really good way of doing it, right? Because then if you forget about this function and you come back to it later, or if someone else looks at it, you know exactly what is going to happen if you use it. So if you take it out and plug it in someplace else, you know exactly what's going to happen. So I don't insist on that at this point, but when we get to assignment 9, I'm going to have you write some pre and post conditions for the functions. So just kind of a little warning in advance. And then I can't remember if I do that in the solutions or not. I used to post 2 versions of the solution to assignment 6, one with pre and post conditions and one with not. I can't remember what I do now. But anyway, I think actually you'll see pre and post conditions when I post the solutions to assignment 6. Okay. Any other questions before we dive in back into lesson 7? Okay. Okay, what I want is, okay, I want lesson 7 here, so back. There we go. By the way, I don't think I've talked about these trace examples much. So this is my day for trying to think of anything I can possibly talk about before we get into the topic of the day, right? These trace examples are examples of programs that have tricky parameter passing, and your job is to look at each of them, trace through, and see if you can figure out what the output of the program is going to be. They're hard. So I'm going to, maybe you may not want to do it yet because I'm going to go over a couple of them in class. Or I don't know, maybe you want to do it in advance so when you see me do it, you'll kind of have some perspective and be able to know what you did and see what you did that was wrong. Anyway, what I want to say is that there's going to be a lot of questions like that on the second midterm. So a lot of questions like, here's some code with a function calling some parameter passing. What happens? So I would say that if you never studied anything else in this whole class, you never read the textbook, never read the lessons, working through these trace examples is probably the most important thing you can do. Okay. When you do them, what you're going to do is you're going to sit down, work out for yourself what you think the output's going to be. Then you're going to actually put it into your compiler and run it to see what the output actually is and see if you are right. Okay? It's not going to help you very much if you run it first and then try to figure out what the output is. All right. Generating random numbers. So, here's what's going through my brain. I'm trying to decide how specific to be because I want this recording to work in future classes even if I don't give the same assignments. But okay, so I'm going to talk about a specific assignment, and it may or may not be true when you're taking this class. But so what we're doing right now is we're going to do a math tutor assignment, which is basically a bunch of randomly generated math problems the user's going to answer, and then your program is going to give a report and say how many they got right out of how many and what the percent was and stuff like that. Okay? In order to do that, you need to be able to generate random numbers. So I'm going to show you how to do that in C++. Okay? Basically, it is done with the function rand, R-A-N-D. Okay? So really, the only essential new thing that I'm going to tell you, everything else today is going to be kind of thinking through the consequences of this, okay? Which, if someone was really smart, they could sit down and work it out themselves. The only actually new thing that you don't know that I'm going to tell you is that this function returns a random integer between 0 and 32,000 something. Okay, so as an example, I have this little code right here which is illustrating the use of the rand function. In order to use rand, I have to put # include C stdlib at the top of my program. And so then I just have this for loop. And if this part right here is confusing, don't worry too much about it. That just says every fifth number, hit the return button and go down to the next line. Okay, so that's not what we're really talking about here. What we're really talking about here is this line right here, which just says print out a random number. So every time this function is called, C++ generates a random number and returns it. Okay. Now, I've shown you this. It's an expression, right? I have shown you this in a cout statement. That doesn't mean it has to be in a cout statement, right? It could be X gets rand, right? Or it could be X gets 47 times 3 plus rand, right? It's just an expression that you can use wherever you would normally use an expression. Any questions so far? Okay. You understand how that output's getting there, right? No questions about how that output got there? Or do I need to slow down? Okay. Now, in our Math Tutor project, we don't want numbers between 0 and 32,000. Okay, we want numbers, at least for the first phase of your Math Tutor assignment, you're going to want numbers between 0 and 100. So how can we scale these numbers so that we get a result that is between 0 and 100? Any ideas? Okay, one idea is put arguments in the function call. That's a great guess, but that would be something new that you would have to know about C++ that I hadn't told you yet, right? And I told you that what I just said was everything you need to know. So rand doesn't accept arguments. Okay, good guess though. It'd be nice if it did, huh? Yeah. Okay, what if we say rand modulus 101? What are the possible results of that expression? What's the smallest possible result? 0. What's the largest possible result? 100. Okay? So yeah, if I say rand modulus 101, that's going to give me a random number between 0 and 100. Okay? So this is exactly the same thing, except instead of just printing out rand, I'm printing out rand modulus 101, and now I get a bunch of numbers between 0 and 100. Any questions about that? Okay. All right, so that's pretty much it. There's just a couple other points that I want to make. Usually in programming, you're not going to want to just print out a random number and then forget what it was, right? You're probably going to want to do more than just print out a random number. You're probably going to want to remember it, maybe do an operation with it, something like that, right? So normally, you're not going to just see out rand. Normally, what you're going to see is probably something like I said before, x gets rand. Okay, so when you do your math tutor project, that's probably what you're going to see. You're going to see something like, well, I'll just scroll down and show you. You're probably going to see something like this. Num1 gets rand modulus 101. Then you've got num1. You can print it out if you want, but then you've got it, so later on you can do something else with it if you need to. Right? Make sense what I'm saying? Okay. Okay, second thing, notice that the number I put after the modulus symbol is always 1 bigger than the maximum number that I want to generate, right? So if I want to generate numbers between 0 and x inclusive, I'm going to say rand modulus what? X plus 1, right? And now make sure that, so here's that expression. You see that down at the bottom. Num1 gets rand modulus x plus 1. What's going to happen for a lot of students is you're going to forget the parentheses there. Okay, so with the parentheses there, I'm getting a number between 0 and 100 inclusive, right? If I take the parentheses off, what am I getting? If I take the parentheses off, I'm getting a number between what and what? Between, well, okay, I don't want x and then adding 1. I want to just tell me, well, tell me the lowest possible thing I could get and tell me the highest possible thing I could get. What's the lowest possible thing I could get? 1. What's the highest possible thing I could get? X plus 1? I think if I take the parentheses off, the highest thing I can get is x, right? Because rand modulus x, the highest possible number that could do would be x minus 1. And then I'm adding 1, so the highest possible number is x. Okay, so that end is right. That's what we want. We want the highest possible number to be x. But we don't want the lowest possible number to be 1. We want it to go from 0 to 100, right? So just make sure you have the parentheses in there or you're never going to get a 0. Okay? Any questions about that? Okay. Last thing. What I've told you so far will work fine. No, I'm not going to show you that. Will work fine for generating random numbers, but the only problem is every time you run your program, you get the same sequence of random numbers. The way that rand works is that there is something called a seed, which tells rand what the first random number to start with is, and then it has the sequence that it just goes through after that. Okay? So if you want to get a different sequence of random numbers, if you don't want the same math problems to come out every time you run your math tutor program, you need to have some way of changing the seed for the random number generator. The way you do that is with the srand function. So I'm going to call so I'm almost positive there's a way to get my browser and never mind. Okay. Normally I would write what I'm about to say, but I can't think of an easy way to do that. Actually, here. I really do need to get better at this stuff. Oh, look, there's paint. I'm going to use Notepad, though. Okay. So the way that I seed the random number generator in C++ is I would say something like, well, the function is srand, and then I put the seed that I want in the parentheses as an argument. So 47, just as an example. And what that says is that instead of using the normal seed, I believe normally the seed is just 1, I think. So what that says, instead of having the seed for the random number generator be the number 1, have the seed for the random number generator be the number 47. So this will give you a different sequence of random numbers than if you leave that function call out. Okay? Is that going to solve the problem? What's going to happen now? Now I'm always starting with the seed 47, so I'm getting a different sequence of random numbers than I had before, but it's still the same sequence of random numbers every time I run the program. So, any ideas about how I could make it so that there's a different sequence of random numbers every time I run the program? Yes? Okay, so you're going to have to be more specific than that. So you're assuming there's some code above this, right? So okay, so I had a function called before, something like that, and then I could put num1 in here. Okay, will that give us a different sequence of random numbers every time? Well, let me ask you this, okay? When I say rand by itself, without having called srand before it, it always gives me the same sequence of random numbers, right? So so num1, every time I run the program, num1 is always going to get set equal to the same integer. And so the seed in here is always going to be the same integer each time I run the program. Okay, so I'm glad I asked this. Rand gives you a random number. The problem we're dealing with here is that the way it's set up is that every time I run my program, I get the same sequence of random numbers. So every time I run the program, if I call rand 10 times, it's going to give me 10 random numbers, but they're going to be the same random numbers, same 10 random numbers. So the first time I call rand, it's always going to be the same random number. The second time I call rand, it's going to be a random number, but it's always going to be the same random number. That make sense? Yes, right. Right. So if I ran this program over and over again, I'd always get this same sequence of integers. Okay. Any other ideas? Yeah. 100? That's kind of what you were... Okay. I'm really glad we're doing this. So is that gonna? What's that going to do? Okay, so first of all, the srand function seeds the random number generator. So if you call it multiple times, what does that mean? It changes the seed. So if I call srand with a certain number, and then the very next thing I do is I call srand with something else, that just means, oh, never mind, don't seed it to what I said you should, seed it to this number instead. So when I've got this for loop, basically this whole loop is the equivalent of if I just said srand 99. Right? Because what I'm saying is seed the random number with the number 0. Then seed the random number with the number 1. Then seed the random number generator with the number 2. And so the only effect that's going to ultimately have is the last one it did. Yeah. Okay, so I could say num1 gets rand, num2 gets rand. Okay. So then are you thinking the rest of our program would be inside here? Say that again? I'm not sure what you mean by extrapolate that.
Right there, that would give you 10 random numbers into that seed, and then go back to the other for loop, change the count, change the seed, give you 10 more random numbers.
Okay, so I'm not following that exactly, but I can tell you that no matter what you do, there's no way to make it so that SRAM, using the kind of techniques that we've been looking at, there's no way to make it so that SRAM is going to get a different seed. Question. Okay, what if you ask the user to input a number, and then use that as the seed? That actually can work to a point, right? The deal there is that if the user entered the same seed twice, you'd get the same sequence of numbers, right? So that's one downside, I suppose. And the other downside is, you probably don't want to make the user do that if you can help it, right? You don't want the user to be even kind of aware that there's this issue going on. So that's getting kind of closer to a way that we can get a different number each time. Another idea? Okay. What we're going to have to do is we're going to use the operating system clock, which you don't know how to do yet. Okay, so I'm about to tell you. Basically, the operating system clock, we have a function in C++ that gives us the current time just as an integer number of seconds. Okay? My understanding is that this is actually the number of seconds that have elapsed since like sometime in the 1970s. So that will be an interesting mathematical exercise if you're interested, kind of try to figure out how many seconds really have elapsed since, 1972 or something. But so the way this is going to work is, actually, let me just show you. Oh, I don't have it. Okay. You're going to have to start. To start, you're going to have to # include C time at the top. You know what? I have a notebook out here. Let me just do it that way. Here's what we're going to do. Yep. So I'm going to do an entire program here for you so there's no confusion about where anything goes or anything like that. Anybody remember, there's one more thing I need to put up here. In order to use the rand function and the srand function, I need to # include cstdlib. Okay? And actually, it's not a bad idea and fairly common practice up here to say why you're including different things. So, okay, and this would be for this thing I haven't shown you yet. Okay, then inside main, what we're going to say is sran time, and then the time function actually takes an argument, and so it doesn't matter. We don't really care about what that argument does, so we just put a 0 in there because it needs us to put something there. Okay, this line right here, how many times do you want that function to be called during the execution of your program? Every time there's a new count or seed. How many times do you want to seed the random number generator? Once. As it turns out, the answer to that question is one time, right? Because once you've got it seeded, you're set up to get a different number, a different sequence of random numbers every time. Okay? So don't put this statement in a for loop. In fact, you can get into trouble if you put this statement in a for loop that is executing more than one time per second, which is fairly likely. You'll sran the time won't have changed, and so you'll be seeding with the same random number twice. Never mind. Just once at the top of your program, and that's it. And you're done with that. Okay. Then rand is the function that gets called every time you need a random number. Okay. All right. Tell me if there's any questions about that, and if not, we're going to move on. Okay. Okay. All of the functions that we have defined so far in here have had the word void at the front, right? So they've all been void functions. When you call a void function, actually let's look at srand and okay, let's look at those two function calls right there. That's calling a void function, right? So it's taking the place of where you would normally see a statement, right? What's different between that and this function call? Anybody want to try to articulate what the difference is? One's a value returning function. That's true. But if I don't know what a value returning function is, I guess I'm looking for like a more detailed explanation. What's actually happening here is that I'm using this function. I'm not using this function in the place of a statement, right? You see the difference? In this case, I'm calling the function and I'm putting it in my program where I would normally put a statement, like a cout statement or an assignment statement or something like that. Here, I'm calling a function and I'm putting it where I would normally put an expression, right? And the reason for that is that this is a value returning function, which means that when I call it, C++ is going to go do some sort of a calculation or something, and it's going to replace this function call with a value. Does that make sense? Okay, so we've actually been using these now and then. Okay, rand is one example. Some of you might have used, well, let's look at time, actually. Time, oh, I deleted it. Time is actually a void function. It's just, oh, no, you're right. You're right. Duh. There's a value returning function, right? I'm using it where I would normally put a value. Okay. Some of you have used the PAL function or used the square root function or something like that. I'm spacing out here on other ones that we've used, but I'm pretty sure we've used some. Anyway, So I think it's actually fairly natural to use functions this way. Like when I put rand here in my program and then put modulus 101 after it, I don't think anybody went, wait a minute, that's not how you use a function. Okay, I think it was pretty instinctive what's going on there. So now all I'm doing is kind of just formalizing that a little bit and telling you, okay, there's two different ways we're using functions. You may not have noticed, but there are. And here's one way, void function, and here's another way, value returning function. Okay? So the topic right now is value returning functions because we haven't ever yet defined a value returning function. I'm going to show you how to define a value returning function. But let me just say that students rarely find it difficult to understand how to define a value returning function. That's never a confusion for anybody. Okay? I just show you how to do it, and you go, oh, and you do it. What confuses students is how you call it once you've defined it. So that's why I'm like beating this into the ground right now. I really want you to see the difference, okay? So let me do an example using the POW function. So I could say cout POW 2, 3. All right. So anyway, so the POW function is just a function that takes the first argument and raises it to the power that it sees on the second argument. So in this case, what's going to get printed out? 8. Okay. Is anybody confused about that syntax? Is there anyone who looks at that and says, I don't really get what's going on there? I guess I shouldn't ask it that way. Well, I should say this. I think for most people, that's fairly intuitive. I call the function called POW. It's returning the value 8, and 8 is what's going to get printed out. Okay? But for some reason, when students start defining their own value returning functions, they don't quite believe that that's enough. So, for example, one mistake I see a lot is students, let's say that we've defined our own function named POW. The student will think, oh, well, I need to call it first before I can use the value in the expression like I did there. So I'm just going to tell you that, well, the sort of insidious thing about this is that if you put this in your code, it'll work fine. Because if you call a value returning function in C++ and you don't do anything with the value, that's what's happening there, right? I'm calling a value returning function. I'm not doing anything with the value, so C++ just goes on to the next statement and throws that value away. So it's kind of like a no-op. It's not doing anything. So I want you to understand that that is not required. It's not, and I never have quite figured out what students are thinking about when they do that, so I'm not sure that I can prevent that misconception yet. But it's not like you have to somehow prime your function call before you can just stick it right in the expression. Okay? That's how you call a value returning function. Any questions? Okay, so we're going to actually go ahead and write a POW function. Huh. Totally missed that. Anyway, okay, so, oops. I want to get rid of this. Okay, why is this totally different? Usually there's a button over here I can click to get rid of the... Oh, I know what happened. I got out of the application sharing that I want. I think. Yeah. Here's our dev C++. Let's just get a new source file going. Oops, I forgot to make it bigger. Okay, so we're going to have int main here. I'm not going to actually fill that in yet. What I'm going to do is I'm going to create a function named pow. Let's call it power, okay, just so it's different from the actual built-in C++ pow function. So when you define a value returning function, it's exactly the same as when you define a void function, but there's two things that are going to be different. The first thing that's going to be different is the very first thing you type when you define a function. So up until now, every function that we've defined, the first word we typed was always void. Okay? In this case, when we're writing a value returning function, the first word we write is the type of the value that is going to be returned. Okay? We're going to keep things simple, and we're going to write a power function that only works on integers. Actually, I think it's only going to work when the exponent is a non-negative integer. So what's the return type going to be? Int. Okay, so just exactly the same as what we've been doing, except instead of void, I've got int. And then I'm going to have a base and a power exponent. And let's talk about how I can do this. Okay, so this, just for a couple of minutes here, we're not talking about value returning functions anymore. We're just doing a little exercise to see whether we can write an algorithm that raises base to the exponent and tells me the answer. So maybe I'll start off by saying int result. How can I do this? Yeah. So the suggestion was a for loop that multiplies base times base exponent times. The result times base exponent times. So we're doing something exponent times. Well, first of all, does that sort of make sense to everyone? That's what an exponent does, right? So what I'm hearing is we've got a for loop that's going to get executed exponent times. And each time through the for loop, we're going to multiply the result that we have so far times the base again. So result gets result times base. Yes? So someone thinks we should initialize result to 1. First of all, let me ask, what's going to happen if I run it the way it is right now? It'll get weird numbers, right? Because garbage, yeah. Result is uninitialized. I'm saying times that by base. Well, so garbage times base is just more garbage, right? So I need to initialize result to something. So the suggestion was 1. Okay. So let's just, why don't you stare at that for a couple minutes and tell me if you think that's going to work. So how do you even do that? What I would do, I guess, is I would start off with something simple like, what if the exponent is 2? So what if it's 3, base is 3, exponent is 2? So first time through this for loop, result gets 1 times 3, so result gets 3. Second time through this for loop, result was 3, so now I'm saying result gets 3 times 3, which is 9. So result gets 9. And then I'm done, right? Because exponent was 2, so it's 2 times through the loop. So result is equal to 9 at this point. Is that correct? Yeah, that was right. Taking it a step, okay, this is actually a good kind of digression here for a second, okay? Testing your code. What I just did was test kind of the general case, right? Nothing special about that case. It was just kind of, here's a general example. Does it work? When you're testing your code, you always also want to look for cases that are, we call them boundary cases. So kind of unusual cases that might not always work because there's something special about them. So I would say, what if the exponent is 0? Is our code going to work? I'm about half nodding and half shaking. We won't even go through the for loop once, right? So is that what we want, or is that wrong? Anything raised to the 0 power is 1, right? So if exponent is 0, does our algorithm work? Yeah. Result turns out to be 1 because we initialized it to 1 and then we never went through the while loop, for loop. Okay? And then I would say, well, what if exponent is 1? Yeah, that works too. Okay, so I'm satisfied now. Okay? All right. So far I haven't told you the second thing that's different, right? The first thing that's different between defining a void function and defining a value returning function is the first word. That's the return type. The second difference is someplace in your function you're going to have a return statement to say what it is you're returning. In this case, what is it we want to return? Result. That's it. Okay, so let's so actually let me back up a little bit and say one more thing. How should we write that? Instead of saying result gets result times base, that's just result times equals base, right? Okay. Whoa. Sure, I'll save it. It's not going to work? Well, I'm not quite done yet. So I could say something like cout power, what should I say, 3, 4. Oop. What is 3 to the 4th? 81? Okay. And then I need a prototype, right? Just like with void functions. And then, oh, thank you. F9. 81. Probably should have done an indel, huh? Okay. Any questions about what's going on with this code? Yes. Not quite, because that would be an infinite loop. But what you're talking about recursion, which is something that you'll talk about when you take CS11. So I'm not even going to repeat the question. Okay, so all right, so that's it, and I will finish up lesson 8 next time.